Okay, I'm going to assume that it's recording. This is section 1.2. This is my first video, so give me a break. Let's hope it works. The first thing we're going to talk about is the real numbers. So a real number is basically any number you've ever dealt with in your entire life. Anything other than an imaginary number, which is the square root of -1 or the square root of a negative number. So real numbers refers to all numbers that we've dealt with up until this point. The natural numbers are these ones in here, 1, 2, 3. They're also called the counting numbers. They are the smallest subset of real numbers. They have the fewest members. Outside of them, we have the whole numbers. The only difference between the whole numbers and the counting numbers is the number 0. And the easiest way to remember that is that the word whole has an O in it. So that means that 0 is included in the whole numbers. Integers are all positive and negative whole numbers. So any positive or negative whole number is called an integer. That's the most common one that we deal with. You'll hear that word a lot. Rational numbers are tricky because it's any number that can be written as a fraction. So it includes all the integers, but it also includes all numbers that can be written as a fraction. So for instance, 2/3 here. If you put that in a calculator, it's going to say 0.666666667 until it runs out of room. It really goes on forever. It's really 0.6 repeating forever, but the calculator runs out of room, so it has to put a 7 at the end. Basically, a rational number is any terminating or repeating decimal. So any decimal that repeats itself or ends is a rational number. And all of these in here are rational numbers. Okay, so the natural numbers are also whole numbers, the whole numbers are also integers, the integers are also rational numbers, and so on. It's just a regular Venn diagram. Now, these guys over here are the irrational numbers. An irrational number is exactly what you think it is. Anything that's, when you think of something that's irrational, it's out of control, it's crazy, that's what an irrational number is. It's a decimal that never ends and never repeats. It just goes on forever and it never repeats itself. So those are irrational numbers. They're in a little set by themselves. See how there's a line here? So all of these numbers on the left are rational. All of these numbers on the right are irrational. You classify a variable by naming the subset that gives you the most information about the numbers that the variable represents. So if your school is sponsoring a charity race, which set of numbers does not contain the number of people P who participate in the race? So think about what your answer would be for P. It would be the natural numbers, right? So the natural numbers is definitely a solution. But the set of integers contains the natural numbers, and it says which set of numbers does not contain the number of people. And the set of rational numbers also contains the set of natural numbers. The only answer here that does not contain the set of natural numbers is a set of irrational. So your answer would be D. Now let's say that in problem 1, if each participant made a donation D of $15.50 to a local charity, which subset of real numbers best describes the amount of money raised? Basically, it's saying, what kind of number is this? It's not a counting number, so it's not a natural number. It's not an integer, because it has a decimal. But it is a rational number. The opposite or the additive inverse of any number A is -A. It's exactly how it sounds. If you have 5, the opposite or its additive inverse is -5. A reciprocal, also called the multiplicative inverse, is 1 over that number. So if A is your number, then 1 over A is your multiplicative inverse or your reciprocal. And notice that any number times its reciprocal gives you 1. The answer is always 1. So take a look, write down these properties, pause the video if you have to. Make sure you get all these properties in your notes. They're really, really important. Basically, what these properties say is Closure just means that if A, B, and C are real numbers, then when you add two real numbers together, you get a real number. Or when you multiply two real numbers together, you get a real number. The commutative property says it doesn't matter which order you write your sum in. You can write 3 plus 2 or 2 plus 3. You always get the same answer. The same thing goes for multiplication. Think about division and subtraction. Does that work for division and subtraction? Is 3 minus 2 the same as 2 minus 3? And you know that it doesn't. Same thing for division. 3 divided by 2 is very different from 2 divided by 3. So the commutative property only works for addition and multiplication. Same with the associative property. A lot of people have trouble telling the difference between the commutative and the associative property. If you think about the word associate, it's kind of like a group. It's who you hang with. It's what your group is. So the associative property groups things together. On the left, it's grouping A and B and adding C. On the right, it's grouping B and C and adding A. No matter what, whichever ones are grouped together, you're still going to get the same answer. So here we say that A times B in parentheses and then times C, or do we do B times C first and then multiply by A? It doesn't matter, you still get the same answer. The identity. Think about your identity. When you look in the mirror, you see yourself. That's what an identity is. So if you take the number 0 and add it to A, you're going to get A back. 0 is the additive identity because when a number looks at 0, it sees itself. So 0 is the additive identity. It just means if you add 0 to a number, you get the same number. For multiplication, 1 is the identity because when you multiply something by 1, it sees itself. You get your number back. So an inverse is simply an operation that gives you an identity as the answer. So if you have A, what are you going to add to it to get 0, which is the additive identity? And it's just its opposite. So negative A for addition, and for multiplication you're going to do A times 1 over A. Pretty sure you guys have done the distributive property quite a bit in your life, so I'm not going to spend a lot of time talking about that. Okay, pause. There's also two other topics in section 1.2 about graphing numbers on a number line. So let's just do an example. Negative 3 halves, negative 5, 0, 2/3, and 7/4. If you were to put all those numbers on a number line, where would they be? Well, negative 5 is going to go right here. So you would put a dot right here and say negative 5. Negative 3 halves is really negative 1.5, so that's going to go right about here. 0, obviously. 2/3 is almost to 1, but not quite. And 7/4 is almost to 2, but not quite. So that will go right here. You also might have to put a number like the square root of 3. Well, we don't expect you to memorize the square root of 3, but your calculator would tell you that it's 1.7 something. So that would go just a little bit, probably, let's see. A little bit to the right of 7/4 would be the square root of 3. Okay, and then the only other thing you're going to have to be able to do is compare two numbers. So for instance, if we take the square root of 14 and 9, which number is bigger? Now, you might not know the square root of 14 in your head, but at this point in your lives, these numbers should mean something to you. And if they don't, you need to start studying them and memorizing them up to at least 121. This is, let's see, do I have a pointer on here? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on. These are called perfect squares. You need to know what they are. I don't know if you have to make flashcards. Do whatever you have to do to memorize your perfect squares. So you know that 14 falls in between 9 and 16. So the square root of 14 is somewhere between 3 and 4. We don't really care where because we know it's going to be less than 9. So that pretty much wraps up 1.2. There's not a whole lot in there. We're going to do a lot with identifying properties. So we can do that in class. But make sure on the last slide you have your properties written down very accurately. Now we're going to move on to 1.3. 1.3. Modeling with words. Which algebraic expression models the word phrase 7 fewer than a number t? Fewer means less than. Less than means subtraction. 7 fewer than t. Now some of you might have gone here. But if I had asked you what's 7 less than 10, you would have done 10 minus 7. So you know that fewer or less, the number goes second. So your answer is not D, it is C. Which algebraic expression models the word phrase 2 times the sum of A and B? This is a key here. The sum of means you have to have parentheses because they want you to add A and B first and then multiply it by 2. So your answer here would be H. If you start with $20 and save $6 per week, what expression models the total amount you save? So your starting amount is $20 plus the amount saved is $6, and W is the number of weeks, so you actually save 6W. So if you had 150 but you're spending $2 each day, what expression models it? So your starting amount is 150 plus your amount saved, but you're not saving anything here, you're spending it. So that's going to be minus 2 times the number of days. There's your expression. Now notice we're calling this an expression and not an equation. The reason for that is because there is no equal sign here. There's nothing to solve for. I'm simply modeling the situation with an expression. Sometimes we have to evaluate algebraic expressions. We need to actually get an answer. So in order to do that, you need to take the numbers that you're asking to evaluate and plug them into the problem. So here we have 7 times the quantity A plus 4. So we put in negative 4 for A, plus 3 times B, we put in 5 for B, and subtract 8. So negative 4 plus 4 is 0, 3 times 5 is 15, 7 times 0 is 0, 3 times 5 is 15, minus 8. Your final answer is 7. Down here, now you always have to remember your order of operations. Okay, so we want to do exponents first, so we're going to do 1/2 to the second power. That gives us 1/4. And then we're going to want to divide here. So 1 divided by 2, that's where the 1/2 comes from. And then your very last step is adding. And remember, to add 1/2 plus 1/4, you need a common denominator of 4. So your 1/2 turns into 2/4 plus 1/4, which is 3/4. What is the value of the expression 2 times the quantity x squared minus y squared all over 3 when x is 6 and y is negative 3? So go ahead and do that right now and see what you come up with. Pause the video. When you plug in 6 for x squared, you're going to get 36. When you plug in negative 3 for y squared, this is tricky because if you type this on a calculator, it's going to tell you that the answer is negative 9. That's not what this question is asking. it wants you to take the value for y and multiply it by itself. So if you do negative 3 times negative 3, that would give you positive 9. So now we have 36 minus 9 in the numerator. 36 minus 9 is 27, I think. And 2 times 27 is 54. Divided by 3 is 18. So your answer would be 18. Will the value change if the parentheses are, I'm guessing that says removed. Yes. Would the value change if the parentheses are removed? So let's try that. Let's see what happens. So now we have 2x squared minus y squared over 3. I think it's pretty obvious now that you can tell that your expression would change because you would do x squared, 36, times 2, which is 72, minus y squared, which is 9, all over 3. And 72 minus 9, 72 minus 9 is 63. What? 63 divided by 3 is not equal to, what did we say the answer was down here? 18. 63 divided by 3 is something like 21. So yes, removing the parentheses does change your answer. Here are some properties for simplifying algebraic expressions. You all know that when you do a minus b, that's the same as adding negative b to a. If you didn't know that, you do now. Subtraction is the same as adding a negative. Dividing is the same as multiplying by 1 over the denominator. So a over b is the same as a times 1 over b. Distributive property, again, you know. 0 times a number gives you 0. Negative 1 times a positive number gives you a negative number. The opposite of a sum means you have to distribute the negative, so you end up with negative a minus b. The opposite of a difference means you have to change all the signs again. So it really becomes negative a plus b, but we write that as b minus a. The opposite of a product means only one thing gets made negative. And the opposite of an opposite means positive value. Okay, what else do we have to go over? Combining like terms. Sometimes on your test or quiz you'll see this. That means you did not combine like terms. Let's do one example. Like terms are common bases with common exponents. So here we have an x to the second. Here we also have an x to the second. Since they have the same base and the same exponent, we can combine their coefficients. 7 minus 4 is 3, so that becomes 3x squared. Here we have a y squared and a y squared. Same bases, same exponents. So we just add their coefficients, plus 5y squared. That's your final answer. You can't do anything else with it. You can't go any further. Let's try another one. How about negative 3 times 2x minus 7 plus negative 5x minus 2. So we have to distribute this negative 1, so we end up with negative 2x plus 7 minus 5x minus 2. Your like terms are negative 2x and negative 5x, which is negative 7x. 7 minus 2 is plus 5. There's your final answer. We're going to practice a lot of that in class, so don't panic if it's not something that looks familiar to you. Alright, that's it.